Hello, good evening to everyone. Welcome to Unacademy, which is the biggest online education platform for GATE, Computer Science and IT. Here, myself, Malesham Devasane, and hello, Nishu. How are you? Good evening. Yeah. If you're watching this video and you are visiting this channel first time, and if suppose you are enjoying these sessions, please keep liking our sessions to reach many students. Right, we are here to help you all the time, and today I'm going to continue Undecidability third session. So if you are not able to understand this session, please complete the previous two sessions so that this session will become so easy for you. Okay, let's introduce myself before beginning today's session. I've secured early rank 119 and 210 in GATE in my BTech 4th year and 3rd year respectively. Then I've completed MTech from IIT Bombay. Then almost 12 years I am in same teaching field, GATE classes I was teaching, and then I'm going to take the classes for TOC compiler programming on this channel. And if you are taking the subscription for Plus or Iconic on Unacademy, use the code DEVALIVE. DEVALIVE is a referral code to get 10% discount. Also, you will get a guidance from me. So you can contact me anytime if you want any help. Right? This is my profile on Unacademy. I'm working as an educator on Unacademy. So you can visit my profile to watch all my classes. That is unacademy.com/@DevaGateCSE, and click on follow once you visit this URL so that you will get notifications whenever I take classes. And right now I'm handling the subjects like C, TOC, compiler design, and also algorithms in special classes. And why we promote for Plus subscription or Iconic subscriptions? Because these Plus courses will have a structured. What kind of structured courses they are? The practice in new questions, we will have a separate course for that. Learning topics, the theoretical course, you will have separate, and revision separate course, and practicing GATE PYQs separate course, and you will have complete schedule, how many days we are going to complete, and mixed subjects like all 10 to 12 subjects are in the same class, mini GATE. One session will cover all subjects and doubt clearing sessions, and all these benefits are available in Plus and also available in Special, but they are not structured. So preparation by choosing all of them is going to be very difficult. So we always recommend to take the Plus course and take the subscription so that all the Plus courses are visible for you. You can enroll to them. And what is the advantage of the Plus? Plus, you will have a live classes, even though you use DEVALIVE, but live classes from every educator. There is no restriction which course you want to attend the live, and you will have crash courses, weekly tests, and rank improvement batches, and you will have courses in both English and Hindi separately, and you will have a doubt solving sessions. And Iconic plan is different from Plus. What is Iconic is like a superset of Plus. All the benefits of the Plus are there in Iconic. Additionally, you will have a coach and a study planner, and you will have a booster sessions so that you will gain the confidence, and then you will have a personalized test analysis, and also you will have a separate material. Right. And these are the plans for the Plus, and prices are increased from yesterday. This is for 1 year after applying DEVALIVE code 27,225, and the new plan is introduced, that is 18 months is a new plan. If you want to take 1.5 year subscription, you can go for plus 34,650 rupees after applying DEVALIVE code. Similarly, for 2 years, for plus you have 39,600 after applying DEVALIVE. Similarly, we'll have iconic subscriptions. For 1 year, you have 40,500 including discount, and for 2 years we have 54,000 for iconic subscription. So you can choose as per your requirement. If you are going for 1 or 2 years, iconic is more suitable, and that will help you to prepare with right guidance. Yeah, we have a Facebook group, that is GATE aspirants for mechanical, civil as well as computer science. You can join here to get updates from us, as well as we have Telegram channel too, right? So you can subscribe to get notifications from us. Yeah, we have various YouTube channels from Unacademy to give free education to the engineering students, like electrical, electronics, instrumentation from Creatics, and Unacademy GATE mechanical production, and Unacademy Civil, Unacademy GATE Telugu channel, and SSJ, this is our channel, Unacademy Computer Science, and Unacademy GATE questions is a separate channel for previous year GATE questions, and we have other channels too. So please share all these channels with your friends. And you have a complete package on this channel to crack the GATE exam. If you are preparing for GATE, and you have discrete maths, operating system, computer networks, TOC, computer automation, C programming, and also you have a data section. All the courses are available on this channel, and more courses are going to come. Already mathematics is started, and soon very many other courses are also going to begin. Yeah, and if you are watching this video, guys, please like this session and also subscribe if you have not done, and please do sharing is caring, that, right? Thank you so much. Today is the third part of Undecidability, where I'm going to discuss about decision properties. This will continue for 1 or 2 more days to understand the decision properties. Okay, so what, sorry guys, is this, okay, the slide was, okay, this is the right slide. Yeah. In previous sessions, we have seen importance of complement is the first session, and later on, even second session, we have seen synonyms in the first session. Second session, we have seen definitions of the words. We have seen synonyms as well as definitions for these 5 words, and they have equivalent words. You need to remember them. I hope you remember them before beginning today's session. If anybody not aware of these previous sessions, please complete them first, like what is language and what is problem, and what is the differences. Even the previous class I have explained, and how the complement is applied to decidable and semi-decidable problems, and what are the definitions we have. And today I'm going to talk about, this is today's plan, guys, decision properties. And properties are basically 2 types, closure and decision. So what is the difference between them? I will explain first. Then I'm going to talk about mainly, definitions. Then this may be applied today or tomorrow, because already knowing what is decision property is difficult in this session. So I will help you. I will help you how to understand the decision properties for various languages, like regular languages, DCFL, CFLs, recursive and RE languages. Okay, let me begin. What is the difference between closure property and decision property? So this is the first topic today, guys. Yeah, if you are watching this video, guys, please like this session, and also please interact in the comment. So I will look at your comment so that I can reply to your doubts. Fine, let's begin today's, what is closure property? We have studied in the previous chapters, what is the closure property. As closure properties basically is about operations. Which operations are closed, which operations are not closed. We have only two things, either closed or not closed. We have seen like union, intersection, complement. It may be unary or binary, or it could be any array. Right? This is about closure properties. Here, let's say union. I am talking about example union. If you are applying union, now domain is important. Are you taking regular languages? Are you taking finite languages? Are you taking infinite languages? Are you taking DCFLs? Are you taking CFLs? Right? So input is very important. So if you take L1, L2 from the same domain, and we will look at is L1 union L2 is belongs to same domain or not. If it is always belongs to same domain, if I am taking L1, L2 from the regular languages, and regular union regular is always regular, so I can say that union is closed. Union is closed, right? Suppose I am taking infinite languages, right? Infinite union infinite is infinite, so infinite languages are also closed under union. But if I take DCFLs, DCFL union DCFL need not be DCFL, means it is not closed. So this was the closure property we have already learned. Closed means every two elements of the domain, the result is also belongs to the domain, right? So domain and operation are two important things here. Domain and operation. Now today I am going to talk about decision property. Decision property basically depends on two things. You ask me anything, like whether, yesterday I have given examples too, whether given DFA accepts, let's say epsilon. Here this answer depends on yes or no. This is called as, we have a problem. Input, maybe you have given DFA, this is your input. And here I am asking a question, this is a problem. Is DFA accepts epsilon? If you say yes, means epsilon belongs to language accepted by DFA. And if I say no, epsilon not belongs to language accepted by DFA. This is called as decision property. Everybody guys? Closure property, decision property. Closure property, we talk about operation where the input is language or languages, output is result, that is also a language, right? And decision property, input can be anything. Input can be anything, like input can be DFA, input can be a language, input can be expression, input can be grammar, and I might be interested a particular property on the input. If I can understand, if I'm able to decide that property, that is yes or no, then we have a decision property problem. It's a decision kind of a problem, right? So mainly we have problems here, problems. Everyone? Yeah. So we have so many questions in the world, guys, right? In a closure properties, we say is union closed for, let's say, regular languages. This has also become now decision property. Yes or no, right? You are able to decide it. Union is closed because you have an algorithm. Now I converted even closure property into a decision property, guys. Look at that. Is union closed for regular languages? Yes. If I ask, the answer is yes, because we have an algorithm to prove it. And is union closed for deterministic CFLs? We say no. Union is not closed. The reason is we have a proof by example. Proof by example. We have example to prove. Here proof, we have algorithm. We have an algorithm to prove why union of two regulars is also regular. Yeah, this is how we can convert even closure properties to decision properties, but understand these two statements. The closure properties are different, decision properties are different. When we are talking about closure properties, we say regular union regular is dash. Regular set union regular set is dash. The result is either regular or maybe not regular or need not be regular, but we know we have an algorithm to prove it is always regular. It belongs to same domain. So in general, I'm talking about if you are taking the two languages from the same domain, result again may be in the same domain or maybe outside, or sometimes inside, sometimes outside, depends on the example. So this is the closure property. And when I'm asking about a decision, I'm going to ask like this: is regular 1 union regular 2 is equal to regular? Now this is the decision property. Yes or no? Yes or no? We know this is, we have an algorithm to prove yes, regular union regular is regular. But some of the examples like DCFL union DCFL equal to DCFL, it may or may not. That depends on the example. Yeah. So understand the point. So this is a decision property. You can say problem. Here we are talking about closure property, because we are looking at, is it always regular or not? Yeah, anyhow, so closure properties we have studied many times, guys. I think you don't have a problem with the closure properties. Now we are dealing with decision property, so you should understand. And when you look at this closure property, decision property, guys, it's there in every chapter. In finite automata we have studied, like for regular languages. Even this is also, decision properties are also there for regulars. But we have not studied there because of you don't know what is decidable, what is semi-decidable, what is undecidable, what is other two words too. Right? Yeah. Hi, Buhra. Is it clear? Here also we have for CFLs, for DCFLs, even for CFLs, CSLs, but most of the properties for CSLs and recursive languages, these are only decidable languages. Recursives, and for RE languages, RELs. And maybe you can say finite languages, infinite. So many domains are there in the world. So many domains are there in the world. Yeah. Right. For both the properties, for closure and decision properties, we have domains to talk about. But in closure property, result is again language. For decision properties, answer depends on yes or no. Answer depends on yes or no. Right. Here, closure property, we have an operation. Result is language. Result is language. Right. Answer depends on the language. What is the output of the given input and operations? And decision property depends on result is just yes or no. Right? Result is yes or no. Okay, let's talk about what are the decision properties we have. And before this, even I told you closure properties in the previous sessions too. Have you studied closure properties, guys, for various domains? Have you remembered this, like union, intersection? Domain keep on changing as per your interest. But this operation definitions never changes. Complement and so on, so on. These are binary operations, and this is a unary operation. This is about closure properties. Yeah. When it comes to decision, now problems are there. Decision standard problems I am taking first, but later on I will be covering so many problems, so many decision problems. Okay. Here I'm going to talk about the important ones, like we have a property that depends on halting or membership. Second is something like halting problem. First, we should know definition of each word so that we can understand slowly. Emptiness problem and finiteness problem. Totality and something like equivalence, and various problems are there. I'm not writing all of them here. First we will learn definitions of these 6 operations. Bohra, union of language and its complement is always regular. Wrong. If the language is regular, then only union of regular languages is regular, just not union of languages, guys. Union of languages can be anything in the world, but union of regulars is irregular. Remember that. Complement of regular is irregular. You can't say complement of language is regular. Both statements are, carefully use it. Fine. And now what is this definition? So first we will learn definitions. Then later on we can apply, later on we will apply to various domains like regular languages, will apply to DCFLs, will apply to CFLs, will apply to recursive languages, and will also apply to RE languages. Yeah, so we'll apply them later on. Decision properties. Now if you have joined late, guys, please do one thing, just click on like button, okay? Waiting for your likes, guys. And obviously dislikes are common in the world. Okay. Now do you have a clarity between closure property and decision property? Decision property, we have some problem, right? That problem will have an input. Output depends on yes or no. And yesterday I have given all definitions, like if yes and no both are having logic, guys. Yes and no both have logics. If and only if this problem, let's say P is a problem, if and only if P is decidable. Assume P is the problem. Assume P is the problem. Assume P is the problem. Only S as the logic, it means no has no logic. If only S has logic, if and only if P is RE but not recursive, it means semi-decidable but undecidable. SD and UD. Yes has no logic. Yes has no logic. Okay, that no word is okay. S has no logic. Be careful that word. S has no logic. If and only if P is not RE. The problem is not RE. So yesterday I have defined this one. Yesterday I have defined all these words. If anybody is having confusion these words, please watch previous 2 sessions. All these are explained in previous session itself. Previous session we have covered this already. I'm just reminding, what do you mean by the decidable problem? What do you mean by decidable problem? What do you mean by RE but not recursive problem and not RE problem? These three problems are very important for us. Yeah. Now let's move on to membership. So guys, membership you can apply for finite automata, DPDA, PDA, Turing motion, halting Turing motion. This membership problem you can apply for every domain that we have studied so far. Now I'm not explaining any domain now that requires a lot of patience, that requires a lot of time to understand. But I will give one example. Finite automata only. Today I will only talk about finite automata. Remaining I will talk about slowly. Everybody, I will only talk about finite automata. First, what is membership? It's membership like, whether given DFA accepts given string. This is the problem. Whether given DFA accepts given string, right? It's a problem. You may, this question may be asked, right? Is the particular W belongs to language accepted by DFA? Look at that. Another way to ask the same question. Membership problem definition. Definition for finite automata. Definition for finite automata. It's just a definition. Really, we don't know right now decidable or not. Yeah. I'm trying to help you to understand word first. Okay. What it means basically, guys. Suppose you have DFA and you are also asking a string W, and this is the DFA is a machine, you know that it's a machine, and both are inputs. This is the input 1 and this is the input 2. Input doesn't mean always a string, guys. Input can be a DFA, input can be a language. Now we need to verify. Look at, we need to verify is W belongs to language accepted by DFA. So we may get two answers, either yes or no, one at a time. If I say yes, what is the meaning of yes, guys? If I say yes, means W belongs to L of DFA. If I say no, it means W not accepted by DFA. Then we need to interpret them properly. This is the membership problem for finite automata. For finite automata, I am explaining. Only for finite automata, I am explaining, guys. For DFA, for NFA, for regular expression, for regular grammar, for regular language, you can define this. Yeah. And this problem is decidable or not? Even you can answer now, but in future also I'll come back. Is it decidable, guys? How do you know it is decidable membership problem? If suppose W belongs to language accepted by DFA, that means W accepted by DFA. It means DFA, that's a logic. What is the logic I am writing here? I will write logic here. Logic for S. It's not about one DFA, every DFA I can answer it. The logic for S is DFA halts at final. How do you know W belongs to that language? Because the DFA halts at final when we run that W on that DFA. And no means what is the logic? That given DFA halts at non-final for given W. But every problem, do you have that much patience to verify? That's why people will try to answer directly without using pen and paper. So you might have a confusion. If you are looking the problem first time, better to use pen and paper to analyze. Like algorithms, you need to analyze. Similarly, these problems also requires to analyze because you may have algorithm too here. Yeah. Now, we have a logic for both. That is the reason this membership problem for finite automata is decidable. Everybody, the membership problem, this is called as membership problem for finite automata is decidable because you can find out whether the given DFA accepts given member or not, given string or not. Yeah. Clear this point? Yeah. Please keep liking the session if you are joining late. Now, I can't help you for all the motions right now. First, I will define only, guys. How do you define for finite automata, guys? For finite automata, how do you define this problem? Is or whether is given finite automata accepts given string W over any sigma, right? Yes or no only there. And if I ask same question, I can apply for regular expression. Even regular expression also I can ask the question. How do I ask, guys? Is W belongs to language generated by given regular expression. What is given? Regular expression is given, W is given. Previously, finite automata is given, string is given. Similarly, I can ask for even left linear grammar, right linear grammar. For LLG, I can ask is W generated by LLG. That means is W belongs to language of LLG. Yeah. Look at the same problem for finite automata. How many ways you can represent? This all is nothing but regular languages concept. It's all same as the regular languages. For regular languages, you can apply this many ways. Even you have RLG, right linear grammar also. Right? This is about regular language. That's a type 3 languages. Now similarly, can I apply for PDA also? But I'm not saying decidable or undecidable now. I told you this problem is decidable. This one I say decidable, but remaining I'm not going to tell you. Because first I want you to understand the definition first. Yeah. For PDA, how to apply, guys? Is W belongs to language of PDA. It means is W accepted by PDA. It means is W accepted by PDA. Okay, we may have an algorithm. That's okay. Okay. That we will see tomorrow. Do you have really algorithm or not? Today we are looking at definition, guys. And similarly for HTM. What is HTM, guys? Is given W. W is also given. Is given W accepted by given HTM. Two things are given. Two things. It means is given W. W is given. Remember that. Accepted by. This is also given. This is also given, guys. Machine is also given, that is HTM. Both are given. String is given, HTM is given. Is that string accepted by that given HTM? Yeah. So now I'm trying to help you to define the problem name only, guys. I'm not saying decidable, undecidable. This is a bigger topic. This is the bigger topic. Right? Don't answer now anything because I can't help you today. Today I can't help you, guys. Today I can't help you for this. Okay, I need time to explain. I need time. We need time. Right now, don't worry about the answers. Everybody? So, right? Everybody? Do not worry about decidable or undecidable now. Because we do not know first what do you mean by decision? What do you mean by decidable? What do you mean by first a decision property? Okay. Yeah, good evening, Piyush. Now, we will see tomorrow. We will see this session we will discuss in next session. About the following problems. But my focus is only on finite to explain what is each decision property. Okay, let's move on to second property. There is another one, halting problem. What is the meaning of halting problem? How do you apply this problem for finite automata? Just like is finite automata is given halts on given string, let's say W. Is there any such finite automata which never halts, guys? No, right? It's a trivial question. It's a trivial question. If you give me any finite automata, you ask me any string W, it should always halt. Is finite automata whether finite automata halts on W? Yes. You have to say always. Answer is yes. Always. No, never happens. So it is a trivial question for us. Yeah, this is what halting problem for finite automata. If you look at that, yes as the logic because we don't need to verify. No as the logic because we don't need to verify. You ask me any finite automata, I will not apply any algorithm. I will just produce. I'll just produce if that is the finite automata you have given. I'll produce S. I'll produce S. This finite automata always halts. Nobody can say finite automata never halts. Everybody? Yeah. So this is a trivial question for finite automata. It's a trivial. The answer is decidable. It's a trivial problem or trivial question. Right. It is decidable. Yeah. Now let's move to how to use the same name for all different machines, guys. It's halting, right? Halting is only nature of the machine, not nature of the language. It is the nature of a machine. Right. Previously we have membership. Membership you can ask for a language, but language may be accepted by machine or generated by expression or generated by grammar. You can represent anything. So here input is a machine, other input is W. So we are going to ask if M is a machine, is M halts on W? Right? The answer may be yes or no. Really we don't know. We don't know whether we have a logic or not. So we may ask the question, right? Is finite automata halts on W? And very less people they know about it. Halts accepts what is the difference? Halts accepts both are different. Accepts means halts at final. It must be. Halts means it may halt at final or non-final, but it halts. Right? In finite automata, everybody halts. Everybody halts. That's the reason you can say that is also halting machine. Every finite automata is a halting machine. Yeah. So look at the words. How do they play? Halts and accepts both are different. Okay. Now, this halting problem I can extend to other problems too. Like this machine can be finite automata. This machine can be DPDA, or this machine can be PDA, or this machine can be LBA, or HTM, or TM. For all of them, this problem is applicable. Yeah, no means, yeah, M does not halt. S means M halts. Exactly. Right? Now for PD, how do you write? Is PDA halts on W? Is HTM halts on W? Is TM halts on W? Yeah, only on W. The given machine also is different. The given machine also on W. Guys, two questions very dangerous here. Given machine halts, whether given machine halts, whether given machine halts on W, both are different. Both are different, guys. Right? It's a particular string is given here. Only machine behavior. Is that machine indirectly? Is that machine always halts? That's the meaning. That's always right. Yeah. No, Vaishnav. If the string is finite, the machine may not halt. That depends on the type of machine. Guys, do you know halting behavior? Finite automata, DPDA. Tomorrow I will discuss. Oh my God. All these machines halts. No matter what input you give. This is the behavior of the machines. Only Turing machine, no guarantee. Turing machine may or may not halt because it can go to never halt case. It again depends on the machine. Clear? Yeah, guys, keep on liking this session. I want you to, I want to see many likes in this class. Right? This kind of data, this kind of theory, this kind of concepts are not there in any video on YouTube, guys. This really helps you to understand the concepts and support us and like us and share this video, which is going to be very important for us. It's halting problem. Similarly, emptiness. Now I'm not going to tell you even finite automata, because if I'm going to tell you about finite automata, you are thinking about decidable or not. Decidable or not, we are not worried now. Guys, please don't worry about decidability. Worry about the definition. What is the definition, guys? Machine is given. This is given. This is given. Now we have to ask, is M accepts pi? That is the problem name, guys. Emptiness means is given M. M may be any machine. Accepts pi. What is the meaning of this question, guys? It's same as is L of M equal to pi. Is it accepting empty language? You're going to say that. Yes or no. If you are able to say both, then probably it's decidable. Only yes you are able to say, that is RE but not recursive. You're not able to say S as the logic, that is directly not REL. So answers are only at this place. Right? This M you can apply like, is L of FA equal to pi, or is, that's actually in general it's M, but M you can replace with anything. L of DFA also you can say. Like NFA also you can say. And you require an algorithm to support them. Your language generated by regular expression is equal to pi. And similarly, is language accepted by DPDA is pi. Is language accepted by PDA is equal to pi. Like is language accepted by HTM is equal to pi. Look at that. Name is one, but you can apply to any machine, guys. Everyone? Yeah. First you should know the definition, then only slowly we can come to the answers. Right? Abhi to aaj to main nahi bataunga what is these problems are decidable or not. Tomorrow, everything is on tomorrow. Everything is on tomorrow. All its answers on tomorrow. String is not required because already problem is cleared. Emptiness, for emptiness, that problem name says it is language. String is not required now. We are talking about the language. Why do you want a string now? You need to run an algorithm to verify it. Everyone, वो machine check कर रहा है ना? We are checking a machine, is that accepting nothing. What is another name, guys? Emptiness means not only this one, is given M accepts nothing. We are trying to verify is that accepts nothing. Another name of this problem, guys. Everyone, like we have, emptiness, non-emptiness. There is one more problem, non-emptiness. What is non-emptiness? Is given machine accepts non-empty language, non-empty language, remember that. Yeah, non-empty language. What is the meaning of that? Is given machine, another name, accepts something. Some string is accepted, doesn't matter who is that. That means the language is non-empty. If you want to prove language is non-empty, you must show there is somebody accepted by the given machine, right? This is a non-emptiness problem. So this machine you can ask for anything. Finite automata. In that finite automata again you can ask DFA, or you can ask for NFA, or here you can ask DPDA, or PDA, or HTM. Even it is you have LBA, you have TM. All different machines. This question is applicable. Answers may be same, may be different, depends on the problem. Yeah, exactly. If you can show that one string is accepted by that given machine, means the language is non-empty. So if anybody is saying something randomly, guys, suppose M is given. How do I know that is M accept something? How do I know that? Show me there is a one string accepted by M. At least S means at least one string is accepted. At least one string accepted. इसे ज़्यादा भी हो सकता. No need to verify. No means is M accept something or some string? No means no string accepted. No string accepted. No string is accepted by a machine. No string accepted by machine means every string is rejected. Are you clear? No string is accepted means language is empty. So this is language is not empty. Here language is empty. Clear this, guys? Yeah. And similarly, you can apply for any machine there as I told finiteness. And directly I will write a problem, guys. Is given M. M is a machine. M is any machine. Any machine is given M accepts finite language. Language now. We don't ask for the string. Or you can say is given grammar. Given grammar. G can be any grammar like regular grammar or context-free grammar. You can apply for grammar also. If given G generates, is given G generates finite language. How do you say that? It's just like that. Is L of G equal to finite? Whenever also you can write is L of M, language accepted by M, equal to finite. Of course, which finite we really don't know right now. Just theoretical question it is. It is the finiteness. Is this finiteness problem or is it decidable for finite meta or decidable for DPDA or not? Tomorrow we will see it. Okay, today again we are looking at definitions. And finiteness problem is over. Infiniteness. Now just ask, is given M accepts infinite language? accepts an infinite language? That's the problem. If it is decidable, yes, no will have a logic that we will see tomorrow again. This is about infiniteness, guys. Indirectly is L of M. Language accepted by M is infinite. Infinite also called as not finite. Infinite. Now look at other problems. Look at other problems. Totality. Totality means is given M accepts sigma star. Indirectly is L of given M equal to sigma star. That's a totality problem, guys. This is called as total. All the strings are accepted or not. Totality. This is a total. Means indirectly all strings. Next one. Equivalence problem. Is given two machines are equivalent. Do not ignore this question, guys. Indirectly, the machines can be anything. I can ask, is given two regular grammars are equivalent? Indirectly, what is the meaning of this? Is language of M1 equal to language of M2? If you are talking about DFAs. This is an equivalence problem. Is equivalence problem. Yeah. And you can apply for all types of machines. So these are the today's definitions, guys. What we have learned today is just definitions. Tomorrow we'll see many. First we have seen membership. What is a membership problem? Is W belongs to language accepted by M. So what is given here? You must know what is given. Here what is given, guys? In this problem what is given? W is given and M is also given. Like M can be any machine that we are going to talk about from tomorrow. From tomorrow, guys, remember. M is unknown now. In general, it is Turing machine by default. If that question comes. Okay. It's given almost every time. Membership and then halting. Halting problem is M halts. Whether M halts on W. It may be accepted or may not, doesn't matter. Even invalid strings also are set non-final. Is M halts on W? What is given again? Given that W and given that machine. Given M should be given and W should be given, then only you can do verify W is accepted by given machine or not. And what about other things, guys? After this, emptiness, non-emptiness, you already know it. What is non-emptiness? What is given, guys? Is M accepts, not empty string, pi, empty language. Is final accepts empty, means no final may be there, no final should be there after minimizing DFA, right? Similarly, is given a PDA accepts empty. So we have an algorithm to do that tomorrow. We'll do that. Like we have the cases for each kind of machine. And finiteness, how do you write? Finiteness in general is M accepts finite language. Which finite we are not saying here? Finite set. Similarly, I can ask infinite, same logics. Yeah, we have even totality we have seen. Totality, what is the answer? What is the definition? What is the definition? Is L of given machine. What is given? M is given. Equal to sigma star. Sigma star you can write in a program. Totality is over. And what else is there in the list? Equivalence. Is L of M equivalent to L of M2? So whether they are decidable or not, tomorrow we are going to start from here, guys. For Fanata, PDA, DPDA, Turing motion, halting Turing motion, for all of them, these problems will be discussed and more problems also will be discussed, right? So before leaving this session, guys, do not forget to like the session. I know this is the one chapter where you cannot hurry to complete a topic. That is the reason I am not going to answer first. I am going to help you to understand first, so that answer can come slowly later on. So today we have not learned any decision property for any particular machine. So in general, what is the decision property? What do you mean by that problem? So today is just again definitions of a problem names. Okay, so these are my classes on Unacademy. You can visit that 7 p.m. I'm going to conduct a special practice session on Unacademy, and 9 p.m. I'll come back to the same channel for C programming. But I have various other classes on Unacademy free classes, so you can attend them. All these classes are free. Please follow me unacademy.com/DEVAGATE to access my classes, right? And we have various subjects in GATE. All those subjects are taken care by our educators on this channel. Please follow them to learn the subjects from us, right? And as I said, recommend this code DEVALIVE if anybody want to take the subscription. 2 benefits: 1, discount anyhow, it is there with every code, but most important for you is guidance. Right? If you want any personal guidance, you can also contact me regarding the subscription. And please like. Thank you so much. Take care and see you tomorrow. Bye bye. Yeah, tomorrow I'll discuss Piyush. L of m is equal